Right now, as you're watching this video, thousands of stars are being born and dying in our galaxy. But here's what will blow your mind. The way stars die determines if life like us can even exist. And there's one type of star death that's so violent, it could wipe out everything within 25,000 light years. Stick around because what I'm about to show you will change how you see every star in the night sky. I'm talking about the most incredible cosmic cycle happening right above our heads every single night. Most people look at stars and think they're just pretty lights, but they're actually massive nuclear reactors that live incredibly dramatic lives. They're born in chaos, live for millions or billions of years, and when they die, some go out with the biggest explosions in the universe. And here's the crazy part. Without these stellar deaths, you wouldn't be here watching this video right now. Today, I'm going to take you on a journey through the most epic story in our galaxy. And by the end, you'll understand why every atom in your body has a connection to stars that died long before Earth even existed. Here's something that confused me for the longest time when I first got into astronomy. If stars are constantly being born and dying, why don't we see the sky changing dramatically from night to night? I mean, if thousands of stars are dying, shouldn't we notice some of them disappearing? The answer reveals something mind-blowing about the scale of our galaxy that most people never really grasp. The Milky Way is so incredibly massive that it contains somewhere between 100 and 400 billion stars. To put that in perspective, if you could count one star every second without stopping, it would take you over 3,000 years just to count 100 billion stars. That's longer than all of recorded human history. But here's where it gets really interesting. Even though our galaxy is pumping out new stars at a rate of about 1 to 3 per year, and roughly the same number are dying, these events are spread across such a vast area that most happen too far away for us to see with our naked eyes. It's like trying to notice when individual people are born and die in a city of 400 billion people, but that city is 100,000 light-years wide. This creates a fascinating problem for astronomers. How do you study something that takes millions of years to unfold, when human civilization has only been around for a tiny fraction of that time? It's like trying to understand a movie by looking at just one frame. Let me walk you through exactly how this cosmic drama plays out, and trust me, it's more intense than any action movie you've ever seen. Stars are born in what astronomers call stellar nurseries, and these places are absolutely massive. The biggest star-forming region in our galaxy is called the Cygnus X region, and it's about 400 light-years across. That's 2,400 trillion miles. Inside this region, there's enough gas and dust to create millions of stars like our Sun. The process starts when something disturbs a giant cloud of gas and dust. This could be a nearby star exploding, or even just the gravitational pull from our galaxy's spiral arms. Once that cloud starts collapsing, gravity takes over and things get interesting fast. Picture this. You have a cloud of gas that's mostly hydrogen, spread out over dozens of light years. It's incredibly thin, actually thinner than the best vacuum we can create on Earth. But there's so much of it that when it starts collapsing, the center begins heating up. At first, it's just warm, maybe a few hundred degrees, but as more and more material falls inward, the temperature keeps rising. Here's where things get wild. When the center of that collapsing cloud reaches about 2,000 degrees Fahrenheit, something magical happens. The cloud starts glowing, and we officially have what's called a protostar. But it's not a real star yet. It's more like a stellar teenager. It has the basic shape, but hasn't quite figured out how to do the main job. The real magic happens when the core temperature hits 18 million degrees Fahrenheit. At that insane temperature, hydrogen atoms start smashing together so hard they fuse into helium, releasing enormous amounts of energy. Suddenly, you have a nuclear furnace that will burn for millions or billions of years. That's when a protostar officially becomes a star. But here's something most people don't realize. The mass of the original gas cloud determines everything about how that star's life will play out. It's like the universe is dealing cards at birth, and your mass is your destiny. If you're born with less than about 8% the mass of our Sun, you never quite make it to full starhood. You become what's called a brown dwarf, basically a failed star that glows dimly from leftover heat but can't sustain nuclear fusion. These cosmic misfits can actually outnumber regular stars in our galaxy, but they're so dim we can barely detect them. If you're between 8% and about 8 times the mass of our Sun, congratulations, you get to live a nice, stable life for billions of years. These are called main sequence stars, and our Sun fits right in this category. They burn hydrogen steadily in their cores, maintaining a perfect balance between gravity trying to crush them and nuclear fusion trying to blow them apart. But if you're born with more than 8 times the mass of our Sun, buckle up because you're in for a short but incredibly intense ride. These massive stars burn so hot and bright that they consume their fuel at an absolutely ridiculous rate. A star 25 times the mass of our Sun will burn through its fuel in just a few million years, compared to our Sun's 10 billion-year lifespan. Now, you might be thinking, okay, so big stars die young. What's the big deal? Here's where the story gets absolutely insane. When smaller stars like our Sun start running out of hydrogen fuel in their cores, they go through a relatively gentle death process. They puff up into red giants, eventually shed their outer layers to create beautiful planetary nebulae, and leave behind a white dwarf. Basically, a super-dense ember about the size of Earth but with the mass of the Sun. But massive stars? They go out with the biggest bangs in the universe. When a massive star starts running low on hydrogen, it doesn't just give up. It starts fusing heavier and heavier elements in its core. First helium into carbon and oxygen, then carbon into neon and magnesium, then oxygen into silicon, and finally silicon into iron. Each fusion process releases less energy than the last, so the star has to burn hotter and faster just to keep itself from collapsing. Here's the terrifying part. When that core becomes mostly iron, the star is doomed. Iron is like kryptonite to stars. You can't fuse it into anything heavier and release energy. It just sits there, getting denser and heavier. At this point, the star's core is an iron ball about the size of Earth, but with more mass than our entire Sun, heated to billions of degrees. Gravity is barely being held back by the pressure from all that heat. It's like balancing a bowling ball on a toothpick. Then, in less than a second, everything changes. The iron core suddenly can't support its own weight anymore. In a fraction of a second, it collapses from the size of Earth to just 12 miles across. Imagine the entire mass of our Sun compressed into something smaller than Manhattan. The core becomes so dense that a teaspoon of it would weigh as much as a mountain. This collapse happens so fast that the outer layers of the star don't even know what's happening yet. They're still falling inward when they slam into the ultra-dense core that just formed. It's like a cosmic car crash at 30,000 miles per second. The result is a supernova explosion so powerful it can outshine an entire galaxy of 100 billion stars. In just a few seconds, this one dying star releases more energy than our Sun will produce in its entire 10 billion-year lifetime. The explosion is so bright it can be seen from billions of light-years away. But here's the truly mind-blowing part. Remember when I said earlier that every atom in your body has a connection to dead stars? This is where that connection happens. Everything heavier than hydrogen and helium in the universe, the carbon in your DNA, the oxygen you breathe, the calcium in your bones, the iron in your blood, all of it was forged in the nuclear furnaces of stars and scattered across the galaxy when those stars exploded as supernovas. Think about that for a moment. The calcium that makes your bones strong right now was created inside a star that lived and died billions of years ago, long before our solar system even existed. When that star exploded, it blasted that calcium into space, where it eventually became part of the gas cloud that formed our Sun and planets. You are literally made of stardust. Not in some poetic sense, but in the most literal, scientific sense possible. The atoms that make up your body have been on an incredible journey across the galaxy, and they carry with them the story of stellar death and rebirth that's been happening for billions of years. But there's an even more incredible type of stellar death that creates the heaviest elements in the universe. When two neutron stars, the ultra-dense cores left behind by supernova explosions, spiral into each other and collide, they create what's called a kilonova. This explosion is responsible for creating gold, platinum, and uranium. The gold in your jewelry was literally forged in one of the most violent events in the universe. Our galaxy is like a giant recycling plant. Stars are born from the ashes of previous generations of stars, live their lives creating heavier elements in their cores, then die and scatter those elements back into space to become the building blocks for the next generation. This process has been going on for over 13 billion years, slowly enriching our galaxy with the elements needed for planets and, eventually, life. The first stars in the universe were made almost entirely of hydrogen and helium. They couldn't have planets like Earth because there weren't enough heavy elements around. It took billions of years of stellar death and rebirth to create the cosmic chemistry needed for a planet like ours to form. And here's something that should give you chills. Right now, there are massive stars in our galaxy that are in their final stages of life. They could explode as supernovas at any moment, and by any moment, I mean within the next million years, which is basically right now on cosmic timescales. One star that astronomers are watching closely is Betelgeuse, the red giant that makes up Orion's shoulder. This massive star has already started the process of dying. It's been puffing up and getting dimmer, showing signs that it's burning through the last of its fuel. When Betelgeuse finally explodes, it will be visible during the day and will be brighter than the full moon at night. It will be the most spectacular astronomical event in human history. But don't worry, Betelgeuse is about 650 light-years away, which is far enough that its explosion won't harm us. We'll just get an incredible light show that could last for months. The birth and death of stars in our galaxy tells the most incredible story in the universe. It's a story of creation and destruction on scales that are almost impossible to imagine. Every single star you see in the night sky is at a different stage of this cosmic journey. Some are just being born in stellar nurseries. Some are in the prime of their lives, steadily burning hydrogen. Some are aging red giants approaching their end, and some have already died and scattered their enriched ashes back into space. This endless cycle of stellar birth and death is what makes our existence possible. Without the deaths of countless generations of massive stars over billions of years, there wouldn't be enough heavy elements in the universe to build planets like Earth, or complex molecules like DNA, or creatures like us who can look up at the night sky and wonder about our place in the cosmos. The next time you look up at the stars, remember that you're not just looking at distant lights. You're looking at the past, present, and future of cosmic evolution. You're seeing stellar nurseries where new stars are being born, mature stars like our Sun that will burn for billions more years, and dying stars that are in the process of enriching the galaxy with the elements that future planets and life forms will need. And most incredibly of all, you're looking at your own cosmic ancestry. Those stars didn't just light up the night sky, they created you. Subscribe for more mind-blowing space content that will change how you see the universe.